Welcome everyone. In this video lecture, we will solve a GATE 2017 question in which we have to find out the Boolean expression for a cascaded multiplexer. So, in this question, it is very clear that there are two MUX, two multiplexer, which is 2 is to 1, okay, and one other multiplexer is also connected with the first MUX, and the inputs of the first multiplexer is y and 0, and this one is a x is a select line, and for the other numbers the z is the select line and these are the inputs. Okay, so we have to find the value of f, boolean expression f. So before that we have to know the very simple concept regarding the mux, how to write the output expression in case of mux. So I'm just drawing it 2 is to 1 marks. So this one I am saying this one is to 2 is to 1 marks. Okay, and this one is say some output, and this one is say some select line. Okay, and if we are saying the input is say I naught and I1, and this is considered as S bar and S. Depending upon the S, we have to select either I naught or I1. So this y expression is nothing but simply the sum of products term. Okay. So this y is generally we have to write I naught S bar plus I1 S. This one is very important. So this y can be written as I naught S bar plus I1 is the same thing we will use to solve this problem. Okay, so when S is 0, I naught will be the output. Okay, so y equals to I naught when S equals to 0, and y equals to, you can say, I1 when S equals to 1. So this one is the concept. So this one is 2 is to 1 multiplexer, and the output of a mux is nothing but simply the sum of products. So this thing we have to take care. Okay, y equals to I naught S bar plus I1 S. So now we have to come to the question, and the options are given here. So at the end we will find which one is the correct answer. So now, so here what we can observe that this one is the x is the select line, so we can write this instead of this 0 we have to write as x bar, and instead of this x we have to write as x. Okay, so for the time being I am saying this is say some function, say f1. Okay, output of the first mux is f1 is nothing but simply product, so y into x bar plus 0 into x, 0 into x. So it is simply our y x bar. So we can say the f1, the output of the first marks, Boolean expression for the first marks is y x bar. So here we can say we are getting y x bar, and in this line we are getting y x bar whole bar, because there is a not gate or inverter, so it will just invert the output. Now this 0 is again we have to replace with z bar and z. Okay, depending on this select line. So the final expression for the f, we can easily write f as a y x bar into z bar. Okay, plus y x bar whole bar, this one, into z. Okay, once again I am writing f equals to, so this can be written as x bar y z bar plus y x bar whole bar into z. The same expression I have written, but in the option it is not there. Okay, so what we have to do, if such type of thing come, just think about De Morgan's law. Okay, so if we apply De Morgan's law, so where we have to apply De Morgan's law in this case? Okay, so just apply De Morgan's law. X bar y z bar plus then y x bar to the power whole bar. So we can write as y dash plus x bar whole bar into z. Suppose a dot b is this one, so it should be a bar plus b bar. De Morgan's theorem. Okay. Okay. So now what we can write this as a x bar y z bar plus y bar plus this should be x. Okay, x bar then again bar, so it should be x z. So it should be our x bar y z bar plus y bar z plus x z. So now we have to search which one is the in here x bar y z bar, x bar y z bar. So this one will be wrong. X bar y z bar. So this may be the correct one here also, but xz. So xz is there, y dash z, y dash z is there. So our correct answer will be option number B. Okay. So just you have to apply the De Morgan's law, and we have to know this concept to how to write the function. So directly we can write this expression. Okay. So first we have to write f1. So f1 x bar y plus 0. So directly we can write this one. Then it should be y x bar. Then y x bar bar because there is a not get inverter. So again y x bar z bar y x bar bar z. Okay. So after that just write this one. Okay. Then you have to apply De Morgan's law in that section. So again we have to write this, and finally we have to add. So our final answer will be option number B. So this is the simple question related to this cascaded multiplexer. So this is all about this question. So thank you for watching this video.